We are going to see the first chapter, real numbers. In this chapter, they are discussing the fundamental theorem of arithmetic. So, first we must know the theorem and then we can do the sum problems. For this theorem, we must know what is prime number and what is composite number. So, prime number means we already studied that prime numbers are 2, 3, 5, 7, 11, etc. It goes on. So, what do you mean by prime number? Prime number has only two factors, that is, 2 has only factors 1 and 2 itself. 3 has 1 and 3 itself. That is the prime number which has only exactly two factors, that is 1 and itself the number. That is called prime numbers. Composite number means it has more than two factors. For example, if you take 6 means it has the factors as 2, 3, 1 and 6. So it has more than two factors. If a number has more than two factors, then it is called a composite number. So now we must clear about prime number and composite number. Prime number means it has only two factors, that is 1 and itself. Composite number means it has more than two factors. Now we come over to the theorem. In this theorem, they are telling that every composite number can be expressed as a product of primes. That means if we take the composite number 24, so 24 can be expressed as a product of prime numbers means 2 2s are 4, 4 2s are 8, 8 3s are 24. So we can express the composite number 24 as a product of primes 2 into 2 into 2 into 3. That is 2 power 3 into 3. So 2 2s are 4, 4 2s are 8, 8 3s are 24. This is the only way to write the composite number 24 as a product of prime numbers. There is no other way to write 24. So this is the only way. We can change the order of the numbers, that is we can change 3 into 2 into 2 into 2, but there is no other factor other than this for the 24. That is the fundamental theorem of arithmetic. So every composite number can be expressed as a product of primes. And this factorization is unique. Unique means what? So 24 is expressed as 2 cube into 3 only. There is no other way to write 24. Apart from the order in which the primes factors occurred. So the order we can change, but the prime numbers cannot change. So this is the fundamental theorem of arithmetic. For exercise 1.1, they are given the first sum as express each number as a product of its prime factors. The first sum is 140. So we can write 140. We can we can factorize this. So in this number, the number is end with 0. We already studied that if the number end with 0 means we can factorize with 2, 4, 6, 8, anything. So if we can, the smallest prime number is 2 only. So we can factorize with 2 only. So how many 2's in 14? 7 2's are 14. We can down the 0 as it is. And then again it end with 0. So we can factorize the prime number with 2 only. How many 2's in 7? 3 2's are 6. So we can tell only up to 6 only. So we have 7 here. So remaining 1. So we can put 1 in nearby 10. So now the number becomes 10. How many 2's in 10? 5 2's are 10. So again we have to factorize 35. This number is end with 5. If the number end with 5 means we have to factorize with 5 only. So how many 5's in 35? 7 5's are 35. And then 7 is the prime number. So there is no other way to factorize this 7 only. So 7 is 1, 7 is 7. So we can write 140 as 2 into 2 into 5 into 7. So that is 2 square into 5 into 7. So, and then the second sum they have given us 156. So if the number end with 6 means we can factorize with 2 only. Already I told that. So take 15 alone. So how many 2's in 15? 7 2's are 14. Remaining 1. So the remaining we have to put nearby 6. So the number becomes 16. How many 2's in 16? 8 2's are 16. Again it end with the 8. So we can factorize with 2 only. So how many 2's in 7? 3 2's are 6. The remaining is 1. So this become 18. So 9 2's are 18. So if it is end with 9 means we have to add this numbers. 3 plus 9 12. So 12 is a multiple of 3. So we can factorize with 3. 1 3 is 3. 3 3's are 9. So 13 is a prime number. So there is no other way. So only the way is 13 only. So we can write 156 as 2 into 2 into 3 into 13. That is 2 square into 3 into 13. 2 2's are 4, 4 3's are 12, 12 13's are 156. The third sum is 3825. So end with 5 means how to factorize with the 5 only. So 5. Take 38. How many 5's in 38? 7 5's are 35. So 35 means 38 minus 35. We get 3. So put 3 near 2. We get the number as 32. So 32 means how many 5's in 32? 6 5's are 30. Remaining is 2. So we get the number is 25. How many 5's in 25? 5 5's are 25. So again it end with the 5. So we have to factorize with the 5 alone. How many 5 in 7? Only 1 5. So remaining is 2. Put here we get 26. How many 5 in 26? 5 5's are 25. Remaining is 1. So 15. How many 5's in 15? 3 5's are 15. So 153. So it will end with the odd number. So we have to add the digits. 1 plus 5, 6, 6 plus 3, 9. So 9 means it is a multiple of 3. So we can factorize with 3. How many 5's in 15? 5 3's are 15. 1 3 is 3. So again we can add the digits. 5 plus 1 6. So we can factorize with 3. So 1 3 is 3. Remaining 2. 21. How many 3's in 21? 7 3's are 21. We already know that 17 is a prime number. So we can factorize with 17 only. So 117 is 17. So we can write 3825 as 5 into 5 into 3 into 3 into 17. 17. So we can write this 5 square into 3 square into 17. And then fourth sum they have given us 5005. So if it is end with 5 means we have to factorize with 5. 1 5 is 5. Put down 0 as it is. 1 5 is 5. So it is a end with 1. So we can add the digit. 1 plus 1 means 2. So we cannot, it is not a multiple of 3. So we cannot factorize with 3. See, we go on another prime number. Next prime number is 5. So it is not end with 5. So we cannot factorize with the 5. So then move on to the next prime number 7. So we can factorize with the 7. Take 10. How many 7 in 10? Only 1 7. So remaining is 30. How many 7 in 30? 4 7's are 28. Remaining 2. How many 7 in 21? 3 7's are 21. So again we can have to factorize with, if it is factorized with 7 means 2 7's are 14. We cannot divide 3 with 7. So we move on to the next prime number. So next prime number is 11. So how many 11 in 14 means 111 is 11. 14 minus 11, 3. So put 3 here, 33 we get. How many 11 in 33 means 3 11's are 33. So 13 is a prime number. So we can write 13 as it is. 113 is 13. So we can write 5005 as 5 into 7 into 11 into 13. So the last sum they have given us, fifth sum is 7429. So end with the add number means we cannot factorize with the 2. Also, if we add the sum of the digits, 7 plus 4 11, 11 plus 2 13, 13 plus 9 22. 22 is not a multiple of 3. So we cannot factorize with 3 also. So if we check with the prime numbers next and next, we get 17 only, it divides the number. So 17. How many 17 in 17 form is 17 fours are 68. So how many is 17 in 74? 4 17s are 68. So remaining is 6. So we get 62. 62 means, so already we know that 14 17s 4 17s are 68. So we can reduce 1. So 17 threes are 51. So 62 contains only 3 17. So 62 minus 51 is 11. So the number becomes 119. So 17 17s are 119. So we put 7. So again we can check this number. 17 does not divide this number. So next prime number is 19 only, it divides the number. So how many 19s in 43 means 19 twos are 38. So only two 19s in 43. So remaining is 5. So 57. So 19 threes are 57. So we put 3 times. So we get 23. 23 is a prime number. So we put 23 as it is. So 1. So we can write 7429 as 17 into 19 into 23 alone. I think, can you understand? So this is the application of fundamental theorem of arithmetics. That is, every composite number can be expressed as a product of prime numbers in a unique way. Thank you.